So, hello everyone. So today let us talk about the radio interface protocols. So as in any communication standards, like what you saw in OSI model, right? So here also in LTE also the interface is designed based on a layered protocol stack. Okay, which can be divided into control plane and the user plane protocol stack. So here is the diagram of the entire thing. So what all things does it contain? So you can see here, so in this particular diagram, so there is something called as control plane and then there is user plane. Okay. So let us see what are this RRC, then there's something called as PDCP, RLC. Yeah, these are these terms are new to us, MAC and PHY. So this is MAC and physical layer. This is something that we seem to know. Okay, so we'll discuss them one by one. And then again, the packet flow. How does the data flow? So this is from the user side. Okay. And we'll see as and when the packets move from here to here, you know, the each and every layer has something to add to it. And finally, the data will be sent here in form of some MIMO OFDM thing onto the actual media, the wireless media. Now let us see each one of them. Okay, so you can see here every data, every layer has something information. It has some information to add to the data that is coming to it from the top, and something it's vice versa is true at the receiver side also. Okay, so let us see which are these layers. Okay, so the first one is the radio resource control. Okay, so the first one is radio resource control in the protocol stack. So what does it do? Performs the control plane functioning. Okay, so this is more of a control thing. So includes paging. So what is meant by paging, by the way? Paging indicates to the various notification of the various events that occur, right? So phone will be in idle state. Say you have a call, which you might get a call now, or there is a data that you might be receiving just now, or this kind of information. So every event that is going to occur, it is the information, the way communicate, it's called as paging. Maintenance, the release of an RRC connection. So if at all there is a connection that is ongoing conversation or something. Okay, so establishing, releasing the connection, security handling. Okay, security will maybe making sure that the entire connection is secured. Okay, it's got nothing to do with encryption or anything, I guess. Then there is mobility management. Mobility management in the sense maybe moving from one base station to another base station, and the consequences. And then there is quality of service management. So depending on the different types of quality of service needed, the allocation of the various resources like bandwidth, maybe adaptive modulation and coding, right? All those things depend on the quality of service requirement. So all those things are controlled by the radio resource control. Okay. So next is the packet data convergence protocol. That's the second one. So the data, actual data. So this was more of a control thing, right? Just like initiating a call or something. So it came under paging. Then afterwards, once the data, actual data starts, then this PDCP comes into picture. So what does it do, by the way? Main function of the PDCP sublayer to include IP packet header compression and decompression. Okay, so now whenever the data is generated, it will be made into a smaller box, right? Segmentation, right? So it will be made into box, and every box, every data, okay, set of data, OFDM symbols, they are, they consist of certain header. You know what is a header, right? It contains a lots and lots of information about the data, to whom it is meant for the data, what sort of resources have been allocated. So now that itself, the overhead itself should not be bigger. So that is why there is a protocol actually. Okay, so for compression and decompression. Okay, so it includes a protocol. Let us see now. Let me take you to the next page. Okay, the protocol is okay. So here we are. So on okay, here is the protocol. It is robust header compression protocol. So in this particular PDCP layer, you can see all these headers will be compressed using a robust header compression protocol. Ciphering of data. What is ciphering? Ciphering is this encrypted data. Okay. So there is something called a plain text and then cipher. Okay, you might have heard this thing. Signaling, integrity protection for signaling. Okay, so it is like security only, but not for the actual data, but for the integrity protection of the signaling scheme. Okay, so there is only one PDCP entity at the enhanced node B, that is the base station, and the user equipment per bearer. Now this term bearer will come across this. Okay, as and when the time comes. For the timing is okay. So here is mentioned here anyway in this reference, bearer is an IP packet flow with a defined QoS between the packet data network gateway and the user equipment. Okay, so we'll discuss it again in the modules to come. Okay, so for the timing, what we should say in PDCP, there is a header compression that happens, ciphering of the data, then signaling, integrity protection for the signaling is also taken care here. Okay, so after PDCP, what next? Then there is a radio link control. Okay, so which was the earlier one, by the way? So there was something called as radio resource control. Okay, earlier one was radio resource control. Now this one is radio link control. So what is this radio link control, by the way? Okay, the main functions of RLC sublayer. Oh, wait a second. Yes, the main function of RLC sublayer are segmentation and concatenation of data units. Segmentation is, of course, breaking down a larger data into smaller blocks. Then, of course, your header compression, everything taken care. Okay. So, segmentation and concatenation of data units. Okay. Concatenation is combining all the data in a particular sequence. Okay. Why that comes into picture, by the way? Because see here, there is error correction through ARQ. As I told you, there may be a automatic repeat request. As we are talking, this is a hybrid ARQ scheme. If at all the error correction doesn't work, then it will ask for repeat request, right? And once it is done, what's going to happen is the packet before is not in error, the packet sent after is not in error, current packet in error. So once the retransmission is requested and it comes in, you should make sure there is in sequence delivery of the packets to the higher layers, right? So that is where the concatenation of data units, the term came into picture. So because of the ARQ, not all in a block, not all the packets might be in error. Whichever is in error, only that will be asked for retransmission. Then the exact all remaining packets are moved on. So you have to stop it here and make sure that the delivery is in sequence. That is why it becomes very important. Okay. What sort of modes do we have, by the way? So we have one is a transparent mode. There are three modes actually. One is transparent mode, unacknowledged, and acknowledgement. Transparent mode is the one without RLC header addition, because at this particular time, you don't know, this is actually used for random access. Okay, first the network is trying to understand, who actually demanded the resources. Okay. Then of course, any particular data, it maybe has to be segmented and concatenated. Okay, or concatenated, used for specific purposes such as random access. Then afterwards come the unacknowledged mode. Okay, so allows the detection of packet loss and provides, wait a second, this allows the detection of the packet loss. As I told you here earlier, there is ARQ feature here in this radio link control. So this is where you come to know detection of the packet loss provides the packet reordering and reassembly. The whole in sequence delivery is taken care in this particular unacknowledged mode, but does not require retransmission of the missing protocol data units. Okay, so what sort of unit? So protocol data need not be retransmitted. Maybe the actual user data. That's what is asked for retransmission. Okay. Then the third mode is the acknowledge mode. Okay, so this is for the complex one. It is configured to request a retransmission of the missing PDU. Okay, so in the unacknowledged mode, you do not ask for the retransmission of the missing protocol data unit. Here you will ask for the request of retransmission of the missing PDU. Okay, in addition to whatever that is there in this particular mode. Maybe depends on the situation whether you need the protocol data unit also, in case if it has gone in error. Okay. So whether you need it once again to be retransmitted. So for the timing, remember the three modes: transparent, unacknowledged mode, and acknowledged mode. Okay. So then what next? Yes, then there is MAC. Okay. So we seem to know something about this. Is something which we have heard already. Okay. So one more statement was here interesting. There is only one RLC entity at the enhanced node B, the base station, and UE per bearer. Once again, we are not convinced with this term bearer. Okay. Anyway, hopefully all the dots will be joined at the end of chapter 10. Okay. Then there is MAC. So what does the MAC do, by the way? A medium access control. The main function of MAC sublayer includes error correction through hybrid ARQ. Okay. Now you see here the packets are coming in this particular manner from the user. Okay. Okay. So user, there was this RRC, then there was this PDCP, then there was this RLC. Now it has come to MAC. Same is the case with reception also. Okay. Same is the case with reception also. So you can see here we spoke about you coming to know that there is ARQ. You want repeat request, but in the medium access control, there is hybrid ARQ. That means in case the the data can be corrected, then it tries to do it here maybe. Okay, let us see. Let us see. The main function of MAX will include error correction through hybrid ARQ mechanism. Okay, so that means if at all for error correction code can correct the error, then fine, it will be done here. Otherwise, it will ask for ARQ to the higher layer. Mapping between logical channels and transport channels. We'll see it in the next topic itself. What are these channels? Multiplexing and demultiplex of RLC PDUs on transport block. Priority handle between logical channels of one UE. Oh, we will say just the priority handling. Okay. Priority handling, because you can see all these things may be there at the base station. So which user equipment to be given how much priority, maybe that's what it decides, by dynamic scheduling of the resources. Okay. Max sublayer is also responsible for transport format selection of scheduled UEs, which includes what sort of thing. This is more important, which makes sense. Okay. So in MAC layer is where you decide for which user equipment, which modulation format, which code, and which MIMO rank, and how much power levels to be allocated. Okay. So that sort of clears everything. So there is only one MAC entity at the base station. The enhanced node B is the new base station, and one MAC entity at the user equipment. Okay, fine. Then finally comes the physical layer. So having decided the format here, code rate here, the rank, the power, and everything sorted out here at the higher layer, what happens in physical layer? This is what everything that happens near the antenna. Your OFDM modulation, and then MIMO, then equalization, all sorts of things, they actually happen in the physical layer. So this is the layer which which is very close to the communication channel. So actual transmission and reception of the data in form of transport blocks. Okay, responsible for various control mechanisms such as signaling of HRQ feedback, signaling of scheduled allocations, and the channel measurements. Okay. So those were the five layers. Okay, those were the five layers, just like in this the in computer networks we study. Okay, so now let us see the channels, right? As the topic name itself is the channels. Now let us see what are these channels. Let us see the hierarchical channel structure of LTE. This channels, what they mean is actually whatever data, once the resources are allocated, the data doesn't simply contain the user information like my voice or a video that you want to film. There are so many other things. So they have been broken down here, and as and when they move through different layers, so new information gets added up, mostly control information. So that's what we'll study in the topic, hierarchical channel structure of LTE. So to sufficiently support various QoS classes of services, LTE adapts a hierarchical channel structure. So there are three types of channels: the logical, transport, and the physical channels, each associated with a service access point between different layers. Okay. So anything, yeah, these layers, channels are used by the lower layers of protocol stack to provide, wait, some problem with this. Okay, okay. To provide services to the higher layers. Okay. So logical channels provide services at service access point between MAC and RNC layer. Physical channels provide the services at the service access point between MAC and physical layer. Then the physical channels are the actual, data carrying medium itself. Okay. So now let us see this diagram what we have here. Yeah. So there we go. So this is the, what to say, the radio interface protocol architecture and the service access point between different layers. Okay, so there was this before this there was an RRC, right? Before this you can see there was an RRC earlier that was more of a control. This is where actually the user data, right, is coming from PDCP layer onwards. So what all things, by the way, so this is just a summary. This is where the channels are. Channels, logical channels are between RLC and MAC. So that becomes its service access point. Then transport channels are between MAC and the physical layer. Okay. So and this is what we have discussed. What happens in each of these layers? Okay, that was discussed already. Now let us see about the logical channel first. Okay. So what do these logical channels decide, by the way? Logical channels decide what to transmit. Okay. Logical channels decide what to transmit. So what sort of channels are there? So there are two categories it seems. One is a logical control channel and another one is a logical traffic channels. Okay. Logical control and a traffic channel. Let us see all the logical control channels. What do we have here? So basically there are, okay, there is a broadcast control channel, multicast control channel, paging control channel, one common control channel, and a dedicated control channel. Okay. So this dedicated control channel is between a single user and the network. Common control channel is between network and different user equipments. Then you can see here, these are the different types of okay, you can see broadcast and multicast. They are not at all related to one-on-one communication, right? They are just complete different entity altogether. Anyway, let us see them one by one. So, what does a broadcast control channel mean? So, a broadcast control channel is a downlink common channel used to broadcast system control information to mobile terminals in a cell, including downlink system, bandwidth, antenna configuration, and the reference signal power. Okay. So due to the large amount of information carried by the, it's a control channel. I don't know what information, this information, bandwidth, antenna configuration, it is mapped to different transport channels. There is something called as broadcast channel and there is something called as a downlink shared channel. Okay, let us not get confused much here. So for the time being, so it's a channel to a broadcast system control information to mobile terminals. So what sort of information? Downlink system bandwidth, antenna configuration, and reference signal power. Okay. So if that is for broadcast, then what is this multicast? Okay. So multicast is a point to multi-point downlink channel. Okay. So broadcast is meant from one place to every other. Okay, whereas this is a point to multi-point. Okay, not to all the point. A downlink channel used for transmitting control information to UEs in the cell. Okay. So you can see we are not talking about a different types of services like broadcast or multicast. Okay. So whereas this is like the control information is broadcast everywhere, whereas this is a particular information being sent from one point to multi-point, not all the points. So what sort of information, by the way? Transmitting control information to user equipment used by you is that require that receive multicast broadcast services. Okay, not meant for all the users. This is not meant for all the users. Okay. Then there is paging control channel. So as we discussed what is meant by paging, once again we'll come to it. Okay. So a downlink channel that transfers paging information to registered UEs in the cell. Okay. So there's suppose there is a call coming to one particular user only in the cell. So this particular channel comes into picture. Okay. So it's an event, right? Call disconnected. That's an event. So for communication of that. Okay. So in case of a mobile terminated communication session. Okay. Mobile in the sense. So this is pertinent between enhanced node B and the user equipment. Then there is a common control channel. What is a common control channel? It's a bidirectional channel for transmitting control information between network and the UAs when no RRC connection is available, implying the UE is not connected to the network, such as in idle state. Okay. So it is used during the random access procedure. Okay, there are so many user equipments. All of them will not be active, but they are there. They are there. You are getting the network, but then as and when they want to do the communication, so that is when a random access procedure takes care. That's when a random access procedure takes care. Okay, that is when this particular channel comes into picture. So it's once again it's a channel for transmitting control information between network and UE when no RRC connection is available. Okay. That's that. Then there's a dedicated control channel. So this one you will see the difference here. It's a point-to-point bidirectional channel. Okay, so this is not a control channel communicating to all the user equipments. Okay, most of them are idle. This one is a point-to-point bidirectional channel that transmits dedicated control information between the user equipment and networks. Okay, it is used when RRC connection is available. Okay, that is UE attached to the network. So you attach to the network, and that's when a conversation may be going on, a data transfer may be going on, which is very much different than a random access procedure, which is a start of a conversation. Okay. So these were the different types of what are this? The control logical control channels. Okay, that's what we discussed. Okay. Then there are logical traffic channels. Let us see what are the logical traffic channels that are there. So okay, so there are two basically. Okay, in the logical traffic channel, there is dedicated traffic channel and there is multicast traffic channel. What is the difference? Dedicated traffic channel is for a point-to-point bidirectional channel used between a given user equipment and the network. Fine, this is when one-to-one communication is taking place. Multicast is a different thing altogether. So it's a unidirectional point to multi-point data channel that transmits traffic data from your network to the user equipment. Like some, out of 100 people, 20 people trying to stream a serial maybe. So it's a unidirectional. So when they say unidirectional, we can see things are much more simple here. Okay, things are much more simple, and maybe there is no FDD or TDD sort of duplexing thing is not there. So that's why waste resources. That's why separate channels. Okay, so it is associated with multicast and broadcast. Okay, now I'm hoping that you are getting the why separate treatment for the dedicated control and dedicated traffic and the broadcast multicast and the paging. Okay, so one thing is the say a tower is connected to say some 100 user equipments. First thing is all of them will not be active. Suddenly somebody raises a request. Okay, so that's what paging is all about. Some event occurring somewhere, somebody got a call. Okay, that's paging. For that a separate channel is needed. Okay, that means you need not allocate much resources. And then when the call actually happens, that is when you need a dedicated channel for a traffic and for the control between user equipment and the tower, the enhanced node B. Then there are multicast. You can see here this dedicated channels, whatever we're talking about, they are bidirectional. Okay, you can see these channels are bidirectional. Okay, whereas the multicast and broadcast, whatever it are, those services, they are not, they are just unidirectional services, right? So that reduces a lot of load, and it's good to have a separate treatment for the such services and normal services like one-to-one communication. That is why separate channels. Okay. Okay, now what next? Now there is transport channels. Logical channel decided what to transmit. Transport channels will decide how to transmit. Okay, let us see. The transport channels are used by physical layer to offer services to MAC. Oh, fine. The transport channel is basically, where is this particular channel? Let us see the diagram once again. We had this diagram, right? Now see here. Now we can see in this particular diagram, here were the logical channels between the RLC and the MAC. This is where the users are, okay, and this is, it is traveling down like this, and upwards, okay. So RLC and MAC, between them there were logical channels. Now this transport channels are between MAC and the physical layer, okay. Okay. Now, yes, the transport channels. How to transmit? Data is ready. Okay. What to transmit, whether it's broadcast or multicast, paging, or whether it is the, direct information, bidirectional information. How to transmit is decided in this particular transport channels. Okay. So what are the things we are talking about here? So transport channel used by physical layer. Transport channel basically carries with the how and with the what character data is transferred over the radio interface. That means the channel coding scheme, the modulation scheme, and the antenna mapping. So this is where it was decided. Okay, you can see in the logical channels when we discussed, that is where it was informed. Here it is being decided. Okay, so two MAC entities, it seems, one in the U and another one in EU TRAN. Okay, so which will handle the following channels. Which sort of transport channels we have now? Let us see. So now there are downlink transport channels and there are uplink transport channels. Okay, downlink transport and uplink transport channels. First, let us see the downlink transport channels. First, let us see the downlink transport channels. So first there is a, so as usual, as there will be a one shared channel where you don't know, which user specifically, all of them maybe. Then there are the services like broadcast and multicast. Then usually there will be paging for those which are, those user equipments which are not at all, maybe which are not into activity, but will ask for some random access. Okay, not random access, some events occur. Let us see one by one. Let us see them one by one. So first is a downlink shared channel. So what is a downlink shared channel? Used for transmitting the downlink data, fine, including control and traffic data. So associated with logical control and logical traffic channels. So it supports HARQ, dynamic link adoption, dynamic and semi-persistent resource allocation. Okay, fine. So downlink shared channel is for supports HARQ, it seems, link adoption, and resource allocation. Okay. So user equipment discontinuous reception. Okay, this is a nice term that came here. So discontinuous reception is as and when the data is there ready, mobile will be, the user equipment will be using more power, okay, for that. And as and when the data is not there, then maybe it will go into sleep mode. Okay, so such particular operation is called as a discontinuous reception. So save power. Okay. So and again, it will decide whether it's a multicast or broadcast transmission. So the concept of shared channel transmission originates from HSDP, it seems. Okay, to multiplex traffic and control information among different user equipments. Okay, okay. Then yes, broadcast channel. So downlink channel associated with BCCH, logical. Okay, a downlink channel associated with BCCH, the logical channel which we discussed earlier, and used to broadcast system, information over the entire coverage area of the cell. Okay, that means this particular channel is used to convey information. It is used to broadcast the information to the entire, all the user equipments that come under the cell coverage area. Okay, so it will have a fixed format because it's not meant for a particular user. It will be received by everyone, whereas multicast channel, which you see next, is a little different. Okay, so here we are not talking about multicast logical channel. You see the names here. That's interesting. You got here BCCH. This one is BCH. Okay. So what is this BCH and what is BCCH? Now let me take you back here. When we were discussing the logical channels, so there we had also the similar terms, right? See, this was a broadcast control channel. So BCCH, another C meant for the control. This was a multicast control channel, paging control channel. See this additional C just before it. That was meant for a control, that to a logical control channel. Whereas this particular channel was simply named as BCH. Right. This is a transport channel. Okay, you can see this particular thing BCH is just a transport channel, whereas BCCH was broadcast control channel. Okay. So downlink channel associated with BCCH logical channel used for broadcast system info to broadcast system information over the entire coverage area of the cell. Multicast channel, by the way, is associated with MCCH and MTCH. What is this MTCH, by the way? Again, once again, we need to see here. Yes, there was a control and there was a transport and logical channels, right? Something, all terms are getting confused here. MCCH and MTCH. Let us see. Okay. So there was a multicast control channel and multicast traffic channel. So this one is a multicast traffic channel. MCCH was a multicast control channel. Okay, so this multicast channel, by the way, here is associated with those channels only for a broadcast multicast service. So it's supposed broadcast multicast single frequency network. Now this is a new application altogether. The single frequency networks are a different application altogether. What's the big deal by the single application? Now it is something like having a say a radio city 91 point radio city 93.5 red some FM channel. Say it is being broadcast over cellular network. Say okay, let us assume so. Okay, so what is the deal with that particular network? It's a single frequency. Wherever you go, radio city is broadcast on that particular frequency only. When you do that, but when there are several antennas, when there are several antennas, that means towers, okay, all of them, I say they are using the same frequency. One thing is good that there is not much of signaling. Everybody knows which frequency it occupies. But then the problem is the synchronization of the multiple base stations becomes a issue. Okay, they all need to be synchronized base station to multiple user equipment. So single frequency networks, even though looks very simple, if at all use the same single frequency and you increase the power from this one, then it is going to affect all the remaining applications in the other cells. That is why it's all sort of challenging, sort of interesting also. Single frequency networks, and it is simplified here, it seems, which transmits same information on the same radio resource. Okay, same resource block in the first tower also, second tower also, third tower also. But the thing is, synchronization should be there. Okay, that's it. Then there's a paging channel which communicates with this paging control channel also. So map dynamically to allocated physical resources required to broadcast over the entire cell range. Even the broad downlink shared channel, even the broadcast channel was broadcasting paging information. Paging channel is also is used to broadcast. It is to broadcast over the entire cell coverage. Okay. So there are the channels. I think there's one more here. Okay. Yes. Then what sort of uplink transport channels we are talking about? So then there are uplink shared channels. So which are those? Now whatever we spoke about, they were downlink transport channels. Now there is something about the uplink transport channels also. So there is an uplink shared channel. So what is this uplink shared channel? Counterpart of downlink shared channel, as we discussed already. So associated with CCCH, DCCH. Oh God, it's okay. Yes, finally we have got something that we understand. Okay. Supports hybrid ARQ, dynamic link adaptation, and dynamics and semi-persistent resource allocation. Okay. So the processing is described in, again, it has, we will be discussing this in great detail in the chapter 8, where we have dedicated chapter. Then there is something called as a random access channel. Okay, so earlier also there we spoke about random access. Okay, transport channel that does not map, it's not mapped to any logical channel. It transmits relatively small amounts of data for initial access, right? I want to make a call, right? Suddenly a random access, that's what it's called about. Nothing much of the data to carry here. Okay. In case of RRC, state changes. Okay, the processing of RSHs once again. Okay. So that was about the various channels. Then there is a control information also, by the way. There is something called as control information here besides the channel. So which is what sort of control information? Yes, there is a downlink control information. Then there is a control format indicator. Okay. And then there's something called as hybrid ARQ indicator. What are these, by the way? Are these channels? No, no. Different type of control informations. Okay. Control signal. What sort of control signals do we have here between these channels? Right. We saw those arrows. There are some communication happening. So downlink control information. So they say there are some 10 different formats. Okay. That are there. So what sort of formats do we have here? So here you can see the different formats you have is something like uplink scheduling assignment, downlink scheduling for one code word. Okay, there are so many basically. There are so many basically. Compact, compact downlink scheduling for one code word with pre-coding and power offset. Okay, there are so many information here. You need to be exactly communicating what is actually happening here, right? That is why the downlink control information. Other than that, what do we have here? Yes, there is something called as a control format indicator. So indicates how many symbols the DCI spans in the subframe. How many symbols in the sense what? There is so many information to be carried out here, right? So that is why, is it only one symbol only that is downlink control information, or you can see here it can be two or it can be three itself. That means the downlink control information can be a lot of metadata. Okay, so it's sent to the physical control format indicator channel. Fine. So one thing, bottom line, control format indicator is just to indicate how many symbols does this DCI span. Okay. HARQ indicator is to indicate whether any ARQ requirement is given or not. So ARQ indicator channel. So H for 1 indicates a positive acknowledgement, and 0 indicates a negative acknowledgement. So probably all these things will come as some bits in a particular register maybe. Okay, so sometimes you need a retransmission and sometimes you don't. And if at all they are being given, there need to be some handshaking signal. That is what this acknowledgement and no acknowledgement come into picture again. So as I told you, in the chapters to come, all these things will be simplified. Okay, so let me stop here.